Postal manufactures in the USA and has a complete range of hard-facing products used in more than 75 countries. We are the only company in the Americas dedicated exclusively to manufacturing hard-facing alloys. With most welding companies, hard-facing is only part of what they do. With us, it is 100%. We focus all our time, energy, and resources on hard-facing. These include a wide range of flux-cored wires, electrodes, powders, and tubular electrodes. We have formulated alloys that offer wear-resistant solutions for all industries, including mining, crushing, construction, energy power generation, logging and wood processing, foundation drilling, earth moving, road building, dredging, quarries, recycling, farming, and oil and gas exploration. Most people have heard of tubular wires and flux-coated stick electrodes. But did you know that a tubular electrode has been developed that has the advantages of both? All welding electrodes used for joining are made with a solid core wire and extruded flux coating, which is great for deep penetration. This is not what you want in hard-facing. As welders, we are told to burn it in when joining two metals. In hard-facing, less is more. For maximum performance, you want minimum penetration into the base metal and maximum alloy deposited on the surface of the part. Low dilution is very important when it comes to hard-facing. The more the dilution, the more the alloying elements such as chromium, niobium, or vanadium become diluted by the base metal, reducing the wear properties of the hard-facing layer. Traditional flux-coated welding electrodes have a solid core wire. The electrical current flows down the middle and produces a very strong penetrating arc. The majority of the heat is concentrated in the middle of the weld pool, which is great for penetration. But this is not what you want in hard-facing. With tubular electrodes, the current flows down the tube surrounding the powder core. The electrical energy is used very efficiently to melt the powder core, thereby reducing the amount of base metal penetration. This also helps efficiently melt all the alloys inside the metal tube, producing a more homogeneous deposit. This presentation will focus on tubular hard-facing electrodes, offering many advantages over regular flux-coating stick electrodes. This includes low dilution, lower penetration, and less warpage on thin parts, smaller heat-affected zone, lower amperage, any welding power source, out-of-position weldability, higher deposition rate, moisture-resistant coating, and higher alloy content provides superior abrasion resistance. The bottom line is better performance, longer life, lower cost, more versatility, and less waste. Tubular electrode construction is offered in 3 diameters: 1/4 inch, 3/8 inch, and 1/2 inch. Stub end, which allows all diameters to fit standard electrode holders. Steel tube. It contains powder alloy fill and is sealed to prevent contamination. Alloy powder fill. The high-density alloy powder fill results in the highest percentage of deposited carbide available. Flux-cored wires and conventional hard-facing electrodes have about a 45% alloy fill. Particle size is small, between 40 to 100 microns. Tubular electrodes are typically 55% to 70% alloy fill, and a much larger particle size can be used. They are up to 1,000% larger than flux-cored wires and conventional hard-facing rods. Thin flux coating. The exclusive moisture-resistant flux coating eliminates the need for heated storage. And end seal. The graphite-sealed end provides an instant arc strike and prevents starting porosity. The graphite-coated end generates CO2 upon the initial strike. This is accomplished when the graphite combines with oxygen in the air to provide additional gas shielding. Now, let's look at conventional hard-facing electrodes. Conventional flux-coated hard-facing electrodes have a mild steel solid core wire. The heavy flux coating must contain all the alloys required. They produce a heavy slag deposit, which must be chipped between each pass. Large diameter core wires require a high amperage, which results in higher heat input, increased warpage, and deeper penetration, which leads to high base metal dilution. That's when the alloy mixes with the base metal and reduces the alloy's performance. Recovery rate is typically only 60%. In other words, for every 10 pounds you buy, roughly 4 pounds are wasted due to stub loss and slag generated. They have limited out-of-position operation. Typically, up to an 1/8-inch diameter can be used for vertical and overhead welds. There is a limited number of alloys available due to the manufacturing process. Heavy flux coatings are susceptible to moisture pickup, which results in porosity. Have you ever had porosity in a weld due to moisture when using conventional flux-coated stick electrodes? Postalloy tubular electrodes with their moisture-resistant flux coating solve that problem. Note that there is no porosity, making them ideal for use in humid environments or outdoors. Now, onto tubular hard-facing rods. Tubular electrodes contain a high percentage of alloy particles packed in a steel sleeve under high extrusion pressures. The tubular rods are dipped in a thin, moisture-proof flux coating. They're manufactured 18 inches long. Typical hard-facing electrodes are 14 inches long. Here are the advantages of tubular electrodes. Tubular hard-facing electrodes have up to a 95% recovery rate. For every 10 pounds you buy, up to 9.5 pounds are deposited to the part, with very little waste. Tubular electrodes contain a high alloy content. Using conventional flux-coated hard-facing electrodes, we usually advise depositing 3 full hard-facing layers to guarantee the chemistry and wear properties of the deposit are fully achieved. But tubular electrodes and the high alloy content in the first layer allow acceptable properties to be achieved using only 2 layers. With tubular electrodes, a wider range of hard-facing alloys is available to meet your specific needs. They have a high deposition rate, depositing metal 3 times faster than ordinary electrodes. The larger size particle increases the surface area of the carbides. The lower welding currents result in less heat input, minimal warpage, and less base metal dilution, including less burn-through. The moisture-proof thin flux coating requires no ovens or special storage, and there is no slag to remove. The 1/4-inch size operates in all positions. All tubular electrodes run on either AC or DC polarity. All sizes, 1/4-inch, 3/8 inch, and 1/2 inch, fit conventional electrode holders. Observe the heavy smoke volume generated by a conventional hard-facing electrode. Notice the difference when welding with a tubular electrode. As you can clearly see, tubular electrodes generate less smoke volume than conventional hard-facing rods. This is extremely important when welding in confined areas with poor ventilation. As you can see by the graph, the tubular hard-facing electrodes run at about half the amperage of a conventional hard-facing electrode. Once again, less is more. Let's see how easy it is to weld with a 1/4-inch Postalloy tubular electrode. Set the machine at 90 amps DCEP and place a 1/4-inch steel plate vertically in the vise. Holding the electrode perpendicular to the top edge of the plate, strike the arc holding a short arc gap and weld the edge of the plate. Notice the easy strike of the electrode and the smooth operation of the rod. Notice the excellent edge retention and control of the deposit. Now let's see the vertical and horizontal welding characteristics. On the vertical face, angle the electrode between 15 to 20 degrees down. Strike the arc and, holding a short gap, proceed slowly down the vertical face approximately 2 inches. Without breaking the arc, proceed horizontally to the right for about 2 inches. Continue to run vertical up using a 1-inch wide shelf technique. Each pass should overlap the previous pass by 50%. Notice the lack of slag interference with each pass and the good control of the deposit. Notice how easy the mild steel plate cuts compared to the tubular electrode edge deposit. Now, let's weld with a 1/2-inch Postalloy tubular electrode. Set the machine at 240 amps DCEP. Place a 1/2 inch thick mild steel plate flat on the welding table. Run a stringer bead approximately 2 inches. Notice the easy initial strike, the smooth operation of the rod, and the lack of slag interference. Now, run a second 2-inch bead side by side, tying into the first bead by 50%. This is the proper bead overlap technique recommended for hard facing. Let's take a look at recommended hard facing patterns for longer wear life. For rock applications, hard face parallel to material flow. For sand applications, hard face perpendicular to material flow. For a combination of small and large material, hard face using a crosshatch pattern. For good abrasion and impact resistance and to reduce distortion, use a dot pattern. Postalloy tubular hard-facing products are available in a wide variety of chemistries. The basic range of products starts with high-alloy chromium carbides, which are ideal for screw conveyors, quarry and crushing equipment, construction, and earth-moving equipment. More complex and metallurgical alloys include additions of niobium, vanadium, and tungsten for increased abrasion and heat resistance up to 1500 degrees Fahrenheit. These are ideal for use in steel mill sinter plants, boilers, and blast furnaces. The last group of alloy tubular electrodes includes tungsten carbide bearing products. These are used for extreme abrasion and fine particle abrasion where the media is hard and sharp. In addition to the products presented in this video, Postal Industries has the ability and expertise to manufacture a product for your specific needs. Contact Postal Industries headquarters for more information. Also, be sure to visit our website for a complete list of hard-facing products and hard-face application information.